Hello friends, welcome you all. In previous lecture, we are discussed the laboratory test. In that, we are discussing the fineness test in sieve test and a Blaine's air permeability test. Then normal or standard consistency test, and lastly initial and final setting time test. Continue with this. Let us see the next test, that is soundness test. For soundness test, we use the apparatus called as Le-Chatelier apparatus. Okay, here we can see the Le-Chatelier apparatus. Okay, this is glass plate and this is weight. Okay, here it is, and this is the plant. Okay, so this Le-Chatelier apparatus consists of small split cylinder of spring brass of thickness 0.5 mm. Okay, forming a mold of 30 mm internal diameter and height of 30 mm. On either side of this split, okay, two indicators with pointed ends. These two indicators with pointed ends are attached, and the distance of these ends to the center of the mold is 165 mm. Okay, here we can see the distance between the this end to the center of the mold, you can say, is 165 mm. So let us see the procedure for calculating the soundness of cement. So first we take the 100-gram cement sample and add water 0.78 times to that of water required for its standard consistency to prepare the homogeneous cement paste. Okay, so we take the 100 grams of cement and we adding the water 0.78 times P, that is P is the normal consistency or standard consistency. After that, this fill the cement paste in the mold of Le-Chatelier apparatus completely by keeping non-porous glass plates at top and bottom respectively, and keep lid weight on it. Okay, in this figure here we can see the glass plates are put top and bottom of the Le-Chatelier apparatus and weight put over it. Okay, over it, this glass plate. Next point is keep this assembly at room temperature for 24 hours so that it gets sufficiently hardened. Then now measure the distance between the two indicator arms of apparatus as D1 mm using the measuring scale. Okay, what we have to do? We have to firstly measure the distance between these two arms. Okay, that is D1 in mm. After that, then keep this set into the tempo water bath under the boiling water at a temperature 100 degrees Celsius for 3 hours continuously, so that the cement will expand due to temperature. Then remove the mold from the water bath and measure the increased distance between two arms as D2 mm. Then calculate the amount of expansion, that is soundness, of given cement as a D2 minus D1 mm. This soundness should not be greater than 10 mm, that is expansion of cement should be less than the 10 mm, so we can call as the cement is sound as per IS code. Okay, for ordinary Portland cement, rapid hardening cement and low heat cement, this expansion should not be greater than 10 mm. Okay, so this is the procedure for soundness test. uh, let us see once again what we have to do for soundness test. We take this Le-Chatelier apparatus, take 100 grams of cement, put the 0.78 P water, that is P is the standard consistency of cement. Okay, then this paste put in this mold. These both glass plates are put bottom and top of this Le-Chatelier apparatus and put this weight over it. Then keep this assembly in room temperature for 24 hours so the cement paste is hardened. Okay, So measure the distance between these two arms, that is d1 in mm. Then put this assembly in the water bath, that is the temperature of that water is 100 degrees Celsius for 3 hours. After 3 hours, remove this assembly and again measure this distance between these two arms. So the distance between these two arms, that is d2 mm. Okay, so d2 minus d1 is the soundness of that cement. Okay, and it should not be greater than 10 mm. So for ordinary Portland cement or rapid hardening or low heat cement, it should be less than 10 mm. So we can call as the cement is sound one as per IS. So hope you understand the procedure of soundness test. Let us see the next, that is compressive strength test. Here we can see the mold for the compressive strength test. The mold size area of this mold is 50 centimeters square. Okay, both sides are 7.07 by 7.07 mm. Okay, so let us see the procedure for the compressive strength test. First, we take the 200 grams of cement and 600 grams of standard sand and add the water 3 by 4 plus 3%. Okay, P is the standard consistency of cement. Okay, how we it calculate, we are discussed in earlier lecture. Okay, so this is P by 4 plus 3 for standard sand. Okay, when we are using the ordinary sand, we use the water P by 4 plus 3.5%. Here we can use, here we using the standard sand, therefore we use the water P by 4 plus 3% of that combined weight of cement and sand. Prepare the homogeneous mortar. Okay, we have to take cement, standard sand and put the water. So we prepare the homogeneous mortar. Okay, second point is fill this prepare mortar in the tube of mold size 7.07 centimeter side by proper compaction. Okay, compact the filled mold on a vibrating machine for 3 to 5 minutes. So we have to put this assembly over the vibrating machine for 3 to 5 minutes. Okay, so we are removing the air bubbles which are present in the cement mortar. Next is the keep these fill molds at a room temperature for the 24 hours and 90% humidity for initial hardening. After that, remove this cube mold and keep cement cubes under the fresh water for curing 7 days or 14 days or 20 days, 21 days or 28 days. Then remove this cube from the water after curing period and keep it under the compression testing machine, that is CTM, for testing. So apply the compressive load at the rate of 35 Newton per mm square till the failure of cube, and note down the failure load in kilonewton. Okay, which is shown by the red pointer of dial gauge. Then calculate this compressive strength of cement cube by dividing the failure load in newton to cross sectional area of cube in mm square. Okay, so we are note down the reading, that is failure load in kilonewton. We have to convert it into newton, that is 10 raised to 3 newton. Then dividing this load into the cross sectional area of cube. So the cross sectional area of cube in mm square is 70.7 by 70.7. So multiplying this, dividing by this area to this load, we get the compressive strength in Newton per mm square. Okay, calculate the average compressive strength for 3 test cubes in Newton per mm square. So we have to calculate the strength at least for 3 cubes, so we can get the average for the test cubes. So next is the storage of cement. Okay, how we can store the cement? Here we can see the storing some cement bags. Okay, so what are the precautions to be taken while storing of cement? Storing the cement. Okay, cement is stored because the cement is hygroscopic in nature and therefore it can be easily absorb the moisture from the air. So cement should therefore be protected from dampness, okay, and high humidity, okay, as it can be rapidly lost its strength and get transferred into the lumps, rendering it unsuitable for use. So during the monsoon, we know every year there is a considerable damage to cement due to the incorrect storage and transportation. Therefore, it is important to have the proper storage arrangement at the consumer's end. Okay. So what are the precautions we have to taken for this storage of cement? Let us see one by one. First, this cement should be stored in a special watertight shed, okay, with a dry and damp-proof doors or waterproof walls and leak-proof roof. Okay, so bag these bags should be we have to stored in the watertight structure. The side of walls of shed should have a minimum to 30 mm or 9 inches brick masonry plastered on both side faces, so it is waterproof or leak proof. Okay. Next is the stacking should be a 30 centimeter away from wall with 1 meter gap between the two rows for easy handling. Okay, this stack here we can see the stack. Okay, this is stack. This stack should be away from the 30 centimeter or 300 mm from the wall. Okay, so these dampness of the wall should not be affect the these cement bags. Okay, and the distance between these two rows should be a 1 meter for easy handling of these cement bags. Next is the bag should not be stacked more than 8 to 10 bags vertically. Okay, here we can see the bags. These bags should not be stacked vertically. 8 to 10 bags, more than 8 to 10 bags. Okay, next is the width of the stack should not be exceed 3 meter. Okay, one stack width should not be greater than 3 meters. Then stacking should be lengthwise and widthwise alternatively. Okay, here we can see this stack. Okay, here we are we are completely see here where cement bags are stored in a lengthwise and widthwise. One row is we are putting the lengthwise and other is a widthwise. Okay, so this alternatively we have to store it. Okay, next is the stacking should be a wooden planks 300 mm above the ground floor to avoid the dampness of that floor. Okay, so here we can see the stack should be above the ground level of 300 mm at least height. Okay, this height should be at least 300 mm. Next is the exhaust fan and the window should be provided for ventilation. Okay, so the dampness should not be affect the cement bags. Next is the bags should be stored in a such way that the bags received first should be used first. This is a very much important point because we know the if the cement bag stored more than the 3 months, it reduces its strength. So the bags which are received first should be used first. Okay, to avoid the strength loss. Next, in addition to this, we can use the polyethylene sheet. Okay, should be used for the all cement bags. Okay, so the water or the dampness should not affect that cement bags. So these all precaution we have to taken while the storing the cement. Okay, so next is the effect of this storage on the strength of cement. Okay, as we know the cement is susceptible for the hydrolysis. It may undergo the hardening due to the atmospheric moisture. Therefore, the strength of this cement goes on decreasing with increase in the period of the storage. Here we can see one table. Here we are period of storage is given and the strength of corresponding strength of cement is given. Means if the we are storing the cement up to the 3 months, it gives the 100% strength. Okay, but if cement period storage is up to 6 months, it reduces strength up to the 25%. That is, the strength of cement is 75% only. After 1 year, it gives the strength 60%, means the reduction in strength up to 40%. After 2 years, it gives the strength up to 50%. Okay, that is half reduction in the strength. And after 3 years, it is 45% strength is given by cement. Okay, that is up to 55% reduction is happened. So this is the effect of the storage of cement on the, if we are store the cement for long time, it reduces strength considerably. Okay, so hope you will understand this session. Okay, thank you.